What if I told you that time travel might not just be science fiction? From Einstein's relativity to quantum mechanics, the possibility of traveling through time is more real than you think. But is it truly possible? Or are we trapped in a one-way journey to the future? In this video, we'll explore the most mind-blowing theories of time travel, and what science really says about bending time itself. Before we talk about traveling through time, we need to understand time itself. Why does time move forward? This is called the arrow of time, governed by entropy, the principle that disorder always increases. That's why a broken glass doesn't reassemble itself. But does this mean time can never move backward? Not necessarily. Albert Einstein gave us the first real scientific theory of time travel, relativity. According to his equations, time slows down as you approach the speed of light. This is called time dilation. Astronauts aboard the International Space Station age a few milliseconds slower than people on Earth. Now imagine traveling near the speed of light. Could we time travel into the future? For the passengers, time would slow down, while for those on Earth, it would continue as usual. Think about it like this. Imagine two identical twins. One stays on Earth while the other boards a spaceship and travels at near the speed of light for, say, 20 years. When the spacefaring twin returns to Earth, they'll find that their Earthbound twin has aged much more. The traveling twin would have effectively time-traveled into the future. But can we build a real time machine? It would take an enormous amount of energy to accelerate something as massive as a spaceship to those speeds. But the principle of time dilation has been experimentally confirmed. Astronauts aboard the International Space Station, for example, age a tiny bit slower than US Earthlings because they're moving at high speeds in orbit. It's a small difference, but it's measurable. And it proves that Einstein was right. Time is relative. So while traveling to the future like they do in the movies might still be a long way off, Einstein gave us the first real scientific basis for time travel. He showed us that time is not a rigid, unchanging thing, but a flexible fabric that can be warped and stretched by gravity and motion. And that opens up some pretty mind-blowing possibilities. Alright, so Einstein showed us how to travel to the future. But what about the past? That's where things get really interesting and where we enter the realm of what seems like pure science fiction wormholes. Now, wormholes are theoretical tunnels or shortcuts through space-time. Imagine folding a piece of paper in half so that two distant points touch. A wormhole would be like punching a hole through that fold, creating a shortcut between those points. Einstein himself, along with physicist Nathan Rosen, explored this idea using his equations of general relativity. They found that these Einstein-Rosen bridges, as they're called, could potentially connect not just different points in space, but also different points in time. But here's the catch. Wormholes are incredibly unstable. They'd collapse faster than you can say flux capacitor, unless they were held open by something called exotic matter. And what is exotic matter, you ask? Well, it's theoretical matter that has negative mass and energy density. Sounds like something straight out of Star Trek, right? The problem is, we've never actually observed exotic matter. It exists only in the realm of theoretical physics. But if we could somehow find a way to create or harness exotic matter, it might be possible to create stable wormholes, potentially opening up the possibility of traveling not just to distant stars, but also to different points in time. Of course, there are still a lot of ifs and buts here. Even if wormholes exist, and even if we could stabilize them, navigating them wouldn't be a walk in the park. Imagine the precision needed to enter a wormhole at just the right time and place to end up where, or, you want to go. But hey, the universe is full of surprises. And who knows, maybe someday, wormholes will be the key to unlocking the secrets of time travel. Now, time travel isn't just about mind-bending physics, it also raises some really thorny paradoxes. And one of the most famous is the grandfather paradox. It's a classic thought experiment that highlights the potential logical inconsistencies of time travel. Picture this, you build a time machine, travel back in time, and accidentally kill your grandfather before your father's even born. Now, if your grandfather never existed, then neither would your father, and neither would you. So, how could you have traveled back in time to kill your grandfather in the first place if you were never born? See? A paradox. This thought experiment has puzzled philosophers and physicists for decades. It seems to suggest that if you could travel to the past, you wouldn't be able to change it in any fundamental way, because doing so would contradict your own existence. Some physicists have proposed that the grandfather paradox could be resolved by the existence of multiple timelines or parallel universes. In this view, traveling to the past wouldn't change your original timeline, but would instead create a new, branching timeline. So, if you killed your grandfather in the past, it would create a new timeline where you were never born, but it wouldn't erase your own existence in the original timeline. But multiple timelines and parallel universes are still very much in the realm of speculation. We don't have any definitive proof that they exist. The grandfather paradox remains a fascinating puzzle, and it highlights the profound philosophical and scientific challenges posed by the idea of time travel. Now, if you thought wormholes and relativity were mind-bending, hold on to your hats because we're about to dive into the quantum realm. Quantum mechanics is the study of the very, very small, the world of atoms and subatomic particles, and in the quantum world, things get really weird. One of the strangest aspects of quantum mechanics is the idea that particles don't exist in definite states until they're observed. It's like they're in a blurry superposition of all possible states at once, and only when we observe them do they collapse into a definite state. This weirdness of the quantum world has led some physicists to propose some pretty wild ideas about time travel. One idea is that time travel might be possible through quantum entanglement. Entanglement is a bizarre phenomenon where two particles become linked, even over vast distances, so that measuring the state of one particle instantly determines the state of the other. Some physicists have speculated that it might be possible to use entanglement to send information back in time. Imagine entangling two particles, then sending one particle back in time. Because they're entangled, any changes you make to the particle in the present would instantly affect its entangled partner in the past. Now I know what you're thinking. This sounds like it violates causality, the idea that cause always precedes effect. And you're right, it does seem to contradict our everyday understanding of how time works. But the quantum world doesn't always play by the rules of classical physics. Another mind-blowing idea that comes from quantum mechanics is the many worlds interpretation, also known as the multiverse theory. This theory suggests that every time a quantum measurement is made, the universe splits into multiple parallel universes, each representing a different outcome. So in this view, time travel wouldn't be about changing the past, but about accessing different branches of the multiverse. You wouldn't be erasing history, you'd be creating a new one. These ideas are still highly speculative, and there's no guarantee that they're even possible. But the fact that they're being seriously considered by physicists shows just how far our understanding of time has come since Einstein. So far, we've been talking about the theoretical possibilities of time travel. But have there ever been any real-life cases of time travelers? Well, there have been plenty of stories and claims over the years, some more convincing than others. One famous example is the story of Rudolf Fentz, a man who allegedly appeared in Times Square in 1950 wearing clothes that were decades out of fashion. According to the legend, Fentz was disoriented and confused, claiming he had just come from 1876. He carried with him old currency and a few other items that seemed to support his story. However, investigations later revealed discrepancies in the Fentz case, and it's generally considered to be an urban legend. Then there's the infamous time-traveling hipster photo that made the rounds on the internet a few years ago. The photo, taken in 1941 at the reopening of the South Fork Bridge in British Columbia, appears to show a man dressed in modern clothing, a hooded sweatshirt, sunglasses, and a graphic tee, surrounded by people in 1940s attire. Some people claimed he was a time traveler, while others argued that his clothing wasn't as anachronistic as it seemed, and that he was likely just a fashionable guy for his time. And let's not forget the countless stories of people claiming to have traveled to the future and back, often with vague descriptions of futuristic cities and advanced technology. While these accounts can be entertaining, they're usually anecdotal and lack any concrete evidence. So, while there have been plenty of claims of time travel, none of them have stood up to scrutiny. But hey, absence of evidence isn't evidence of absence, right? Perhaps there are time travelers among us, carefully concealing their identities and abiding by some temporal prime directive to avoid altering the past. Or maybe, just maybe, we're the first generation to crack the code of time travel. Only time will tell. So, where do we stand with time travel? Is it just a science fiction fantasy, or could it one day become a reality? Well, the truth is we don't know for sure, but what's exciting is that physicists are actively exploring the possibilities, from bending space-time with relativity to harnessing the strangeness of the quantum world. Could we one day build a real time machine? Some physicists believe it's theoretically possible, but enormous challenges remain. The key might lie in quantum physics, black holes, or even technology we haven't yet discovered. It might require us to rethink our understanding of the universe and the very nature of time itself. The mystery of time travel isn't solved yet, but it's one of the most exciting frontiers of science. And who knows, maybe someday we'll be able to journey through time as easily as we travel through space today. If you enjoyed this deep dive into time travel, hit that like button and subscribe for more mind-expanding science videos. And tell me in the comments, if time travel were real, where or when would you go first?